Okay, so last class we did a bunch of parent functions. Now there are two more parent functions that most likely you haven't done or you haven't done a lot of. So the first is called a piecewise function. And it's called a piecewise function because it's different pieces of graphs pulled together in one function. So it looks like f of x. We've got f of x, and then we got an equal sign, and then we have the fancy bracket here. And that fancy bracket is telling you all of these little pieces go together to make a graph. If you read it straight across, you've got 2x plus 3, and then there's a comma. After the 2x plus 3 comma, there is a domain restriction. This is telling me that the only x values that we can use for 2x plus 3 are less than or equal to 1. Those are the only x values that can be used for 2x plus 3. And when we talk about less than or equal to, and when we talk about graphing and shading and open dots and closed dots, does anybody remember about less than or equal to, if that's going to be an open dot or is that going to be a closed dot? Does anybody remember when we did that stuff like years ago? If it's equal to, that's the closed dot, right? So this would be like greater than or equal to. This one would just be greater than. Less than works the same. It would be a closed dot. So this is the domain. We've got a closed dot. And since we're using Kami, I really like to say how I like to color coordinate these things. So I'm going to do this equation in blue. And then is red an okay color to do the other one in, or would somebody prefer a different color? Or pink? Pinkish red? Okay. Just want to check because some people have colorblind. All right. So what we're going to do is, let me go ahead and get that pink one going. The other one, again, this is the domain, meaning these are the x's I'm allowed to use. I'm only allowed to input values that are greater than 1. And greater than would mean this is an open dot. So 2x plus 3. What x's could I use in a table of 2x plus 3? What does this domain tell me? Caleb, what x's am I allowed to use according to that? Could you give me a couple? Sure, sure. And it's a line, so I really don't need that many values. Okay, how about for the other equation? We've got x, and then we've got negative x plus 4. What x values am I allowed to use for the other equation, Caroline? Okay, can you give me some examples? All right, now I left a space when you said 2, 3, 4 because I do want to know where it is at 1, but it's going to be an open at 1. It's going to be an open dot. It's not going to actually equal 1. It could equal 1.00000000001, but it can't equal 1. So that's why we're going to have an open dot. So I do want to put that in there. So the number that is occurring in both tables is the number that separates that domain. That x is 1 would be kind of a border between the two pieces. So I'm going to just write that down. Maybe I'll use red for that one. So the border is x equals 1. So I'm going to go ahead and graph x equals 1, but I'm not making it a solid line because it's not really there. It's just separating my two pieces into halves. So I'm going to have half of one graph, half the other graph. And that's where it splits. So since these are lines, I might be able to graph these somewhat fast if I think about slope and y-intercept. Or we can just plug in numbers. I guess it doesn't really matter. But with this first one, if I plug in 0, what is 2x plus 3? If I plug in 0, what is 2x plus 3? Yeah, that's the y-intercept. So 0, 3 is on it. So if I plug in -1, we get -2 plus 3. That's 1, -1, 1. If I plug in 1, I get 2 plus 3. That's 5. This is the line. I could use my slope to find more points, or I could just use my line at this point to draw it. The line is not across the whole graph, though. It is only on the half that is less than or equal to 1. So this is a piece. This is one piece. Okay? Then the pink one, I'm going to try to rewrite that word. It was kind of messy. So I know it's going to be open at 1, so I'm going to go ahead and plug in 1, and I get -1 plus 4, which is 3. So 1, 3 is an open circle. 1, 3 is an open circle. And then we've got 2, -2 plus 4 is 2, 2, 2. That can be closed. My slope is -1, so really I can just use my slope to find some more points. I don't really need the table. And then the line to draw. It's only through half the graph. So your blue and your pink lines should never cross each other. There should not be a place where both of them are at the same time. One is on the left, one is on the right. They do not pass through each other. You need to make sure that your picture looks like mine. I can even zoom in more. Every year I walk around. We've always done this on paper before, so it's a little bit easier for me to really walk around fast and see people's papers. Every year I walk around and somebody's not looking at my answer and has them like crossing. They have to stop at that border. Okay? So I'm sure everybody's ready to go before we go on. Oh my gosh, you can draw lines. Okay, so there's something wrong with yours. You should only have one arrow for each piece. But one of them's on both sides. You can only have each piece on one side. You guys without styluses, is that right? Stylon? Styluses? I don't know. Without them, please invest. It's going to be a pain in your, you know what, if you don't get your record. You know you have lines, right? Yeah. You know you have lines, right? It's called markup. If you want to know something else, all right. Yeah, if anybody needs a graphing calculator chart, feel free to plug it in over there. But it is, make sure your name's on it because somebody could just go take it. All right, the next one, is that all we need to do? I can't remember if that's all we need to do. Sketch, just sketch. Okay, good. The next one. So we've got two pieces. Let's talk about what's open and closed first. Oh no, this thing turned off. There we go. So the first one, is that going to be open or closed when we say x is less than 2? Open or closed? Yell it out. Open. Good. Oops, that's lines. How about the second one? Open or closed? Closed. There always has to be one open next to one closed. Okay? And I'm going to go ahead and make that border. That border is going to be x equals 2, because that's the number where they open and close at. X equals 2 is a vertical line at 2. There's my border. So x squared minus 4. What kind of values? Sarah Knowles, what kind of values could I put in my first table for x squared minus 4?
1, 0, -1, and 2.
Would I put 2 in?
No.
So I do want to put 2 in because I still need to know where is it open. I want to have that open dot at 2. We have to know that we don't close the dot in, but we still want to put that 2 in the table. And I'll fill that out in a second. Let me just set up my other table. And then the other table would be with x minus 1. And Tyus, can you give me some values for the second table that I could use? Okay, so now I'm going to stop before I go a little further with Tyus. You said exactly what I would have said, but then I would have thought about it a little bit longer because I'm the teacher. And I would say, do I really want to plug in 3 into that square root? Because if I do the square root of 3 minus 1, I'm getting the square root of 2, and I don't know how to graph that. So maybe we think a little bit harder about good values. And is that Lydia? Did you have some? Yeah, just to make it a little bit easier on myself, right? So Lydia, do you have a value besides, because I don't want to do 3. I changed my mind about that one. 5, right? 4 is not going to work. 4 by itself is a perfect square, but I take away 1 and it's not. So 5 would be a good one. What's another one that could be a good one, Chris? 10. And after that, we're pretty much off the graph, so I'm not going to put any more in there. So if we plug in 2, we get the square root of 1, which is 1. If we plug in 5, we get the square root of 4, which is 2. And then I'm guessing this is the square root of 9, which is 3. Okay. And I didn't fill out my blue one. I guess I got to fill that one out too. Remember, if you square a number, it becomes positive. So this would be 4 minus 4 is 0. 1 minus 4 is negative 3. This would be negative 4. This would be 0. All right, so when I'm looking at my blue one and I go to graph it, I have 4 points that I could plot, but I also have an open point. And you make sure that it's open. It should be right on the border. 2, 0 should be open. And then I will plot 1, negative 3, 0, negative 4, negative 1, negative 3, 2. If you don't have enough points to see that parabola, if you have a big empty space, maybe plug in another number. Maybe you remember enough about Algebra 2 that you actually know where the next point would go without even having to plug it in. For example, I know that the parabola has like out 1, up 1, out 2, up 4, out 3, up 9. So I could actually just move and put a point where I just know it's going to go without even using it in the table. And hopefully anybody who had me last year can do that, because we had to write that over so many times. That one day we had to do it like 24 times in a row. Do you remember that? Is it scarred into your memory? Okay. And then I'm only going to graph it on the left side of my borderline. And you do your best to make a beautiful parabola. On the right side, we can use a closed dot. 2, 1, 5, 2, 10, 3, and we have our piecewise. I'll give you a second to catch up. See why we're not going to be entering in things in Canvas today, right? There's no way we can do that. You guys say, if you're ready to go on, look at the next one. See if you're getting this. You don't have to wait for me if you're like, all right, I get it. You're so lost, then wait for me. Does anybody have like tissues or hand sanitizer or? I'm going to go over in a second, but that helps. So the next one, what's different about this one is when you look at the domains or the equations, there's 3 equations. That's telling me there's going to be 3 pieces of a graph, 3 different pieces. That tells me there's 2 borders. So where are the borders for this one? There's 2 of them. X equals, you're just going to look at your domain. What's one of the borders? X equals, yell it out. -3, and X equals 2. So that's where I like to start. I like to set up those borders so I don't forget about them. And I'm saying that because you guys probably don't know this. I have the ability to see into the future. Did you know that? So I know where people in this class are going to make mistakes. And I know that because it happens the same every single year. I try to do a better job of really stressing. Throw those borders in there first. Every year, somebody's going to make a mistake. So I'm just trying to really overstress it. One year, we're going to get it right. Okay, and then I've got 3 different tables of values. You don't have to make the table. I just feel like it's helpful for those of us that have never done Piecewise to like see it in a table. So this first one, x is less than -3. I need to pick values that are less than -3, and I'm going to call on Nick because I think Nick can give me some good values for that one. See, I knew you would do that, and that's why I wanted to call on you. Did you hear his answer? He was like looking ahead, and he was like, I want to make this easy on myself. I'm not going to pick 4, or what, -4. What is it? Yeah, -4, because that's going to give me a fraction. I'm going to pick numbers that don't give me fractions. So he said, I'm going to pick -6 and -9. And then he didn't tell me, but he should have told me, also use -3, but remember, that's going to be an open dot. I forgot to write open up here. So we do need to have -3 in there, but maybe write yourself a note. That's going to be open. Don't color it in. I'm going to try to do my next one in green, but the green choices up here are not that great. If green is a color that you can't see, please let me know so I can change it. So for this one, will we have open or closed dots for this one? The second one. Both closed? Yep, both closed. And Kira, could you tell me what values I should have in my table for the middle one? Will you just list values for me? Yeah. Might as well throw them all in there. And then my third one. So that one I'm going to look at up here and it says x is greater than 2. That's going to be open. And Belle, could you tell me x's that I should use? 2, 3, 4. But just to be safe, I'm going to mark 2 as that's an open circle. I want to make sure that I remember that that one's the open circle because it's not really equal to it. All right, let's go fill in our tables. Maybe I'll just start on this pink one since I was finishing there. What do we got? 2 minus 2 squared, that's going to be 0. 3 minus 2 squared is 1. 4 minus 2 squared is 4. I feel like I'm probably going to have some more values in this table. I'll at least do another value. 5 minus 2 squared is 9. And then we're getting closer to being off the graph. So 2, 0 is open. 3, 1. 4, 4. 5, 9. And you should look at it and be like, well, that is quadratic. That is a parabola, so it should have that kind of parabola shape even though it's not the whole thing. It should not be a straight line. The middle one is absolute value, so it should potentially maybe have a V shape, but it kind of depends what part of the V we end up graphing. It could just look like a straight line if we graphed a certain part of the V. Absolute value of x plus 1, so that'll be 3 plus 1 is 4. 2 plus 1 is 3. 1 plus 1 is 2. It'll be 1, 2, 3. So -3 is 4. Is the green kind of light? Is it hard to see? I have a way to make it a little bit easier to see. better, right? No? Okay. All right, and then my blue one, the line. So plug in -6 and let's see, -6/3 plus 5 is -2 plus 5, so 3. Check my math. Oh, I didn't do the first one. Looks kind of right. -3 is 4. And then -6 is 3. And -9 is 2. So what happens when I did the blue one, it was an open circle, but then the green one filled the circle in. That's okay. As long as they don't both have closed in circles. If they both had, especially with between the green and the pink one, if those both had closed circles, it would not be a function anymore because it would fail that vertical line test. So it's okay to have one open and one closed to fill it. What you can't have is we can't have the color sections passing through the borders. They got to stay on their side. Any questions about Piecewise? So they just take a little bit of time. They're not difficult. They just take a little bit of time. Okay. The next page is something called the greatest integer function. And it didn't print out correctly. So we're going to write it. It did for some of them, but not for others. So we're going to write it on there, what it looks like. It also didn't do it in your worksheet, and I wrote a note. I mean, it was like typed, but when it turned into a PDF, it like got rid of the typing, so I don't know. It looks like that. It's kind of like two kind of square brackets, but they have 2 lines instead of 1. If you see that, it's called the greatest integer function. And this is defined as the greatest integer less than or equal to x. So if I put a number in there, we have to think about the greatest integer that is less than or equal to x. And sometimes it's helpful to have a number line when we start doing this. I'll put some numbers on the number line in a second. So if -1, this should be in it, but it didn't copy. If -1 is in it, I need to know the greatest integer that is less than or equal to -1. Remember, integers, no decimals, no fractions. So what number is less than or equal to -1, no decimals, no fractions? It is -1, yes. So because it's equal to an integer already, you just use that integer. The next one is not an integer, it's -1/2. So I'm going to just put like a tiny little number line up here. That's where -1/2 would be. And we need to know the greatest integer that is less than or equal to -1/2. And remember, on the number line, when you think less than, you want to go this direction. So what integer is less than or equal to -1/2? John, what do you think? Yep. The greatest integer that is less than or equal to 1/10. So my number line, here's 1. 1/10 would be about here. Yeah, approximately. What number is less than or equal to 1/10, Caitlin? What integer? Yes. 0. 1.5. The greatest integer that is less than or equal to 1.5. Don't yell it out. Write it down. Think about it. 1.5. Mark, do you know the answer? It is 1. Yep. So you want to round desperately. You desperately want to round, but this is not a rounding. This is basically taking it lower. All right, and then the greatest integer less than or equal to negative 2.1. Again, oh, and it's not drawn. I'm sorry, let me draw it in there. But don't yell it out. I'm going to call on somebody. See if I can catch anybody, or if everybody's doing a good job. Reagan. Would not be negative 2. So if we have negative 2 here, and we have negative 3 here, negative 2.1 is about there. So what's less than?
Oh, negative 3.
It would be negative 3. Okay? That's why I said the number line sometimes just helps us, because our brains really want to go to negative 2 so bad. Okay? All right, now how do we graph it? Again, it's not drawn. It should be here. So how do we graph it? If I input 1, I'll just make a table after this that way. Do I have a table here already? No. If I input 1, I should get out 1 because it's already an integer. But what if I input 1.1? I will get out 1. What if I input 1.5? 1. What if I input 1.9? What's the number that's going to make it change? As I'm going from 1 and counting higher, what's the next number that's going to make it change? 2. When I go to 2, that one is an integer, so that one would that one would be at 2 for the output. If I input something like 2.5, it goes all the way down to 2. If I input 2.9, it goes all the way down to 2. And then this pattern is going to continue. So let's see what it looks like over here. I am going to change the scale on my graph because I know what it's going to look like, and I want it to be like obvious to you guys what it looks like. So I'm going to make this 1 here, and make this 2, and make this 3, just so it's spaced out a little bit. It also allows me to not have to graph as much. You'll see why in a second. So I know for sure at 1, if I input 1 for x, I get out 1 for y. For sure. But I also know that anytime I input from 1 through 2, but not including 2, anytime I input in between here, I still get out 1. I still get out the y value of 1. So what that looks like is this. So we've got a straight constant line because everything from 1 to 2 is always 1 for y. It's constantly 1. But then as soon as I input 2, that line stops. But you can't just end the line. You have to have the open dot saying that it goes all the way up to 9 or 1.9999999. And then now when I input 2, I get 2. So we have this jump. Oh no, I did something to this. I'm trying to graph a dot at 2, 2. My stylus stopped working again. I still haven't figured this thing out. So I'll just push a bunch of buttons until it works. Unfortunately, I'm recording a video while it's happening. Okay, now it's working. All right, at 2 it jumps up, and then it's going to be that constant answer that gives me 2 every single time until I get to 3. Oops, and I didn't go to 3. I stopped it short. Hold on. Forgot I changed my scale. All the way to 3, and then at 3 we're going to have an open dot. If I input 3, what am I going to get out? 3. So that's going to jump up to close dot at 3. We're going to go over and it will open dot at 4. Then it will jump up to 4, and we're going to finish that pattern. Once you have some of the pattern done, it will repeat itself. And we can have transformations on this pattern as well. If you know the general pattern, the parent function, which is this one, we could translate it up. We could translate to the left. We can have stretches on it. If that's too much for you to think about, you can always just make a table like I did. So the graph is blank between each pair of consecutive integers. The graph is constant, which makes it horizontal, between each pair of consecutive integers, and the graph jumps vertically at the integer values. Now let's write the domain and range of this. So what x's can I put into that thing? What x's can I put in? Is there anything that's going to make it undefined? No. I can put anything I want, so domain is all real numbers. The range has an exception, though. What answers am I getting out the range? All real numbers? If I look over here and I started labeling if I wanted to write down every single y value from the table, what would my y values look like? 1, 2, what else? I didn't make my table very big. What else? 3, what else? 4, what else? Can somebody summarize instead of me counting? Yeah.
Wouldn't it just be like all real whole numbers?
So you don't have to say real, because real whole numbers are already real. But whole numbers are just 0 and above. Can it be -1? I didn't put -1 in the table, but did we graph it -1? Yeah. So the word would be integers. So yes, we're going to just say it's all the integers. And that's kind of the name of the function. It's the greatest integer function. So we could just say the integers. It does have a fancy symbol in math. Looks like this. Because it's the integers. It's not, but that's what it looks like. All right, so let's try this one here. Oh gosh, pretty sure it's this. And then this one over here has the space, because I'm pretty sure that's where the thing should have been. So sketch the graph. So for this one, if we use the parent function, we could even use my table. What do we do to the y values after we put in 1 and we get out 1? So if we put in 1 and we just do this integer part, we would get out 1, but then we still need to add 1 to it. So when I input 1, I would actually get out 2. Did that make sense? I don't know if that made sense. So everything's going to be pushed up by 1 point, vertically higher 1 point. So again, if I put in 1, I get out 2. So if I put in like 1.1, I get out 1, but then I have to add 1 to it. So I do the absolute, or not absolute, the integer function first, greatest integer function first, then I add 1 to it and I get out 2. So if I put in 1.5, I get out 1 and I add 1 to it, I get out 2. So all of these, I'm getting the answer of 2. But once I put in the number 2 into my greatest integer, I get out 2, but I still have to add 1 after that, which gives me the answer of 3. So at 2, it jumps up to 3. So we're taking that function that we just graphed and just moving all of these little stairs up one higher than they were originally. So you can use transformations for that. You can make a table for that. Oops, I did that wrong. So you don't have to like graph it to answer this question, but does anybody remember anything about like 2 outside of the function? What happens when we multiply the function by 2, what that does to a graph? That is a vertical stretch, right? So that means whatever the graph is, we're going to take that graph and we're going to stretch it vertically. What do you think is going to happen to this graph if I stretch it vertically? What might happen? If I'm taking horizontal lines, but I'm stretching them vertically, what do you think is going to happen? Caleb, what do you think is going to happen? I can't hear you, hon. The stairs will kind of be like steeper. Yeah, they'll be wider apart. Definitely, that's what's going to happen. So let's choose some values. If I input 1, after I do just that greatest integer part, I would get out 1, but then I still need to multiply it by 2. So I would get out 2. So 1 is 2. If I input 1.1, I would get 1 times 2, which is 2. If I input 1.5, I would get out 1 times by 2, which is 2. It looks like I'm not going to change numbers until I input 2. And when I input 2, I get out 2, multiply that by the 2, and I get 4. So this is going to have an open dot, and then we're going to jump up all the way to 4. So this will follow that pattern. It's just the stairs are going to be like spread further apart vertically. So once you get a few of those, you don't really have a lot more work to do. Just complete the pattern. And if you're not sure, make more points in your table. If it doesn't look right, something actually doesn't look right. I did it wrong. See? If it doesn't look right. Hope you're not just copying down mine. Should have been here. Yep, now it's hard for me to use this Cami stuff because I've never used it before. It was like my first year I'm using it to do notes. I'm a paper person all the way. Are we okay? Doesn't seem too bad. So this is the last section of what we're going to have for our quiz. And on your modules for today, let's see if we can find them. On our modules for today, there is a worksheet, and I wrote in red so you don't miss it how we were missing those greatest integer brackets. So I told you where they need to go. Says number 5 is just around the x, but number 36 only around. I don't know what that means now. Now I gotta bring it back up.
3 is the same as the pound sign, so you probably just didn't shift.
You're right. Clever, smart. Yeah, that must. I'll edit it right now. That probably says number 6 only around the x. There we go. Like, what did I write? I don't even know. Okay. So number 6 only around the x. Number 7 is around the whole x plus 3. So So when you go and you look at those, I know they didn't copy, but I don't know, maybe our computer's newer now and it'll, I can upload it again and it'll fix it, but it wouldn't do it last year. So you can see it's missing stuff. So that's what you just need to add in when you work on it. So you guys have lots of time. You have 35 minutes? Is it 10? Oh, I don't have the thing up. Do I have the thing? Yeah, we have D-lunch. But that's, I took my schedules down.
We get out at,
I think they changed it to 10 now, but it's somewhere. It's somewhere on here. I'll go find it and we'll double check. I'm still recording. I can close that down.